Hello students, let us discuss some of the text question which is in the text exercise question number 23. The question number 23 have the following parts. First question, write the electronic configuration of the following ions. That is, some of the ions are given. You need to write the electronic configuration for these. So let us first solve this problem. So write down the electronic configuration of following ions. So in order to the electronic configuration, I told you make the orbital diagram so that it will be easily you can frame the electronic configuration. So let us make the boxes like this. You know the series which is given by above principle, the series that is 1s, 2s, 2p, 3s, 3p and so on. You try to write in one line, but here the space is not there. That's why I have written in the two line. Try to make it in the one line. So let us do this problem. That is electronic configuration we need to do for ions. So better you first try with the atom, then only you do for the ion. So let us do the first one. The first one is for hydrogen ion, that is H negative is given. But first we do for a hydrogen atom. Atomic number is 1. So there is single electron. Let us do the filling. Filling start with 1s. So 1 electron is there in the 1s orbital. Now only single electron is present in the case of hydrogen. But in the question, it is given that we need to write down the electronic configuration for H negative. H negative, that means negative sign indicate there is a one gain of electron. So that means you have to add one electron. Now where you need to going to add the electron, because there is one extra electron. So we need to add the electron in the orbital diagram. So definitely we need to go in the same order as we have done for electronic configuration. So when one more electron is added, that electron will be get added here. That is in the 1s, that is in the anti-clockwise spin. So we can say that now there are 2 electrons are present in the hydrogen. So we can write 1s 2. So that is all the configuration. So what we got the configuration for hydrogen ion. For the hydrogen ion, the configuration is 1s2. 1s2 is the electronic configuration. So let us do for the sodium ion. For the doing sodium ion, Na plus, first we need to find out the electronic configuration of Na, which have 11 number of electron because its atomic number is 11. So we'll be doing this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and this is the 11th electron. So this is for the case of sodium atom. First we need to find out for sodium ion, Na plus. Na plus means there is one loss of electron from the atom, then it is called as Na plus. So you need to remove one electron. So from where we are going to remove, whenever you are removing the electron, you have to remove from the last electron which is get added here. The last electron that is which we have filled, that is this electron. So you have to remove this electron. Now after the removing of electron, now count how many number of electrons are left. That is 2, 2, 4 and here it is, we can say 6 numbers. So total 10 numbers of electrons are there. So when you count it for the Na plus, there are 10 number of electron. Now when we write the electronic configuration, how we write the electronic configuration? That is 1s2, 2s2, 2p6. When you count the number of electron here, it is 6 electrons. So 2p6. So what is the electronic configuration for Na plus? That is 1s2, 2s2, 2p6 is the electronic configuration for Na+. Next, we'll be doing for O2 negative. O2 negative, that means oxide ion. So for this, first we need to find out the electronic configuration for oxygen atom. O, its atomic number is 8. So 8 number of electrons are there. We'll start the filling. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 number of electrons are there. So we have filled in the way according to the principle, upper principle, Pauli exclusion principle, Hund's rule. We have filled the electrons. But this is for O2 negative ion. We need to write down the electronic configuration for O2 negative ion. That means 2 negative. 2 negative indicates 2 electrons are added. It has gained 2 electrons. So that means you need to add the electron. Now where you are going to add the electron, 2 more electron you need to add. So the sequence will be going the same way as you have done. So where you have ended here. So the next electron will be going, that is 2 more electron you have to add. 1 electron will be here, 1 electron will be here. So when you count it, how many number of electrons are there? Here is 2, here is 2, and here it is 6. So total number of electron is equal to 10. So when you count it, 8 number of electrons are there in an atom, 2 electron is gained, so become 10. So total 10 number of electrons are there. So what is the electronic configuration for oxide ion? That is 1s2, 2s2, 2p6. That is the electronic configuration for O2 negative, that is oxide ion. Now let us do for F negative. F negative, first of all you need to write down the electronic configuration for F, that is fluorine. Fluorine, its atomic number is 9. So now we'll be filling the electron. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 number of electron, but for the case of F negative, there is one addition of 1 electron. So we need to add 1 electron. So when we are adding an electron, we have to add where the next electron get accommodated here. So you should not do here because here there is one space is there. So after filling of this only, it will get into the next one. So you can say that one more electron get added, that is the red color which I have made in the anti-clockwise spin. So this is the added electron. So when you count it, how many number of electrons are there? It is 1s2, 2s2, and here you can find 6 number of electrons. So that is 2p6. So what is the electronic configuration for the case of F negative? That is 1s2, 2s2, 2p6. So this is the way of doing the electronic configuration for ion. Whenever there is a positive charge, you need to remove that much of electron. If there is a negative charge, you have to add that much number of electron. So first of all, do the electronic configuration for that atom and then do for the ion. Then it will be easier. Next question. What are the atomic numbers of element whose outermost electrons are represented like this? That means outermost electron it is given. You need to identify the atom. So first of all, let us do for the first one. The first one is, that is 3s1. 3s1. So let us do for 3s1. First of all, you need to specify the position 3s1. Where is 3s here? This is 1s, 2s, 2p. This is 3s. That means the outermost electron is in 3s orbital. So that means, and you can find it out, there is only single electron is represented here. That is 1s1. It is given as 3s1. That means there is a single electron in the 3s orbital. And we know that when we fill this one, the first electron is in the clockwise spin. And if it is only single means that there is only one electron that is in the clockwise spin. So this electron which I specified with the pink color, this is the last electron, that is the outermost electron. So we know that 3s filling only takes place when after the filling of 1s, 2s and 2p. So when they completely get filled, then only the filling takes place in 3s. So it shows that the inner orbitals like 1s, 2s and 2p are completely filled. Therefore, the last electron is in the 3s. So we need to fill this one. So we'll be filling the 1s, 2s and 2p. Then only after this only the electron will be enter in the 3s. So what is clear from this one? You can count it the number of electron, that is 2 here, 2 here and 6 here and 1 electron is here. So total we can say that 2 plus 2 plus 6 plus 1, that is 11. So we can say that there are total 11 number of electrons. Therefore, which atom specified the atomic number 11? That is sodium. So the answer is sodium metal is the correct answer. So we come up with the metal atom, that is sodium atom, which have the last electron is in the 3s orbital. Now let us do for the next one, 2p3. 2p3, that means the last electron is in the 2p3. That means there are 3 electrons in the 2p. So let us make, it shows that there are 3 electrons in 2p. That means 1, 2, 3. This is 2p. There are 3 electrons in 2p because our problem is 2p3. 3 electrons are there. Only 3 electrons are there. So we have made 3 electrons. And because there is only 3 electrons, it shows that there is no pairing, because after getting the single only the pairing will start. So it shows that only 3 electron is present, so that we have made. So 2p filling only takes place after the filling of 2s and 1s. That means definitely there are electrons in 1s and 2s. After the filling of complete 1s and complete 2s, then only the filling start for 2p. So when we count the number of electron in each, here you can find 2 electron, 2 electron, and here there are 3 electron as given in the problem itself, 2p3. So we can say 2 plus 2 plus 3 is equal to 7. So 7 is the total number of electrons. So atomic number 7 represent an element, that is nitrogen. So what is the answer for this? That is the element nitrogen. Next one, that is 2p5. 2p5, similarly you need to fill the 3p5. You need to fill the 3p orbital. There are 5 electron in 3p. So we need to fill the 3p with 5 electron. 1, 2, 3, 4, 5. So there is the 5 number of electron. And we know that the filling of 3p only begins after the complete filling of 3s, 2p, 2s, 1s. So that means we need to fill this completely. So when you complete these orbitals, complete filling of these orbitals will get like this. So we can say that when you count the number of electron in this, it is 2, 2, this is 6, 2, and here total 5 electrons are there according to the question. So when you count the number of electron, that is 2 plus 2 plus 6 plus 2 plus 5. So you will get, so when we make the sum of this one, we'll get the number of electron as 17. So 17 belongs to which element? That is chlorine is the correct answer. Next question. Which atoms are indicated by the following configuration? Here some configurations are given. You need to answer that which atoms are indicated by this configuration. So because when we are writing the electronic configuration for an element with a large atomic number, so we need to write the full sequence. It will take time. So we can write it in the short form by using the noble gas species, which you can find it here. Noble gas atom species elements are there. So we can represent these elements. These can be taken in order to write the electronic configuration. So that we need to discuss here. So first of all, let us talk for the first one. That is helium is given in the bracket. He is given in the bracket and 2s1. This is given to us. So first of all, you need to find out what is the electronic configuration for helium. When you find it on the sequence, this is the electronic configuration of helium, that is 1s2. So helium represent 1s2, and what is next? That is 2s1. 2s1. Now when you count the number of electron, that is 2 electron in 1s and 1 electron in, because this is the 2 electron here, 2 plus 1. 2 plus 1 give rise to 3. So that means atomic number 3. Atomic number 3 represent for which element? That is lithium. So that means when you compare this one with the chart here, you can find it out in the chart, because it is given He, that is helium, and 2s1. So when you find out the configuration, this one for the lithium, this 1s actually represent for what? It represents the helium, and we have 2s1. So that is 1s2, 2s1. So 1s2 can be written as helium because the configuration of helium is 1s2. So in short, we can write the electronic configuration in this way. It will be more beneficial such type of writing for the such type of element which have large number of electron in it. That means which have greater atomic numbers. Let us do for the next one, that is neon 3s2 3p3. So neon, that is atomic number 10, neon. So in the case of neon, we can find out because it is a stable configuration. So stable configuration, and it have this much number of electron, and all are fully filled electron. So in the place of this much, what we can write? Neon. So neon, that is a neon have atomic number 10 plus, next what we have, that is 3s2 3p3, that means 2 plus 3. So when you make the sum, you will get 15. So that means the element is represented, that is atomic number 15. So atomic number 50 belongs to the element, that is phosphorus. So the element which is indicated this electronic configuration is phosphorus. Next one is the third one. In this Ar represent the argon. Its atomic number is 18 plus 2 electron, that is 4s2 is given. So 2 electron plus 1 electron is given, that is 1. So that is 18 plus 2 plus 1, that is equal to how much? That is equal to 18 plus 2, 20, 20 plus 1, 21. So it belongs to the atomic number 21. 21 belongs to the element scandium. So scandium is the correct atom or the element which represent the configuration, that is this one. So this is the way of writing the electronic configuration in the short method. So instead of writing the all orbitals, what we can do, the particle filled orbital, that can be represented by the noble gas species. So this is the way of writing the electronic configuration in the short wave. So let us find out the answer for these. So first one, when we have tried the first one, what we got, that is helium having configuration 1s2 and 2s1, that is 2 plus 1 3. So that means 3 number of electron, atomic number 3, that belongs to lithium. Second case, Ne 3s2 3p3. Ne have a, that is Ne represent the noble gas species. So that having 10 number of electrons. So total 10 plus 2 plus 3, that is equal to 15, which belongs to the element phosphorus. The last one, the electronic configuration is given argon. Atomic number for argon is 18. So this much is 18 plus 2 plus 1. So when you make the sum, you'll get 21, and 21 belongs to the scandium. So this is all are the answer for the question which we have discussed, that is the third question. So this is all about the 3 questions which we have discussed in this video. So all of you note down these question and answer in your notebook, because it is the one of the quite important type of questions, and usually the exam such type of question will be asked. So thank you.